Hey everyone, welcome back. This will be part 2 of our Mario clone tutorial series. I am Chris and we are going to get right to it, and the first thing we're going to do is we're going to start with our camera follow script, and this script is going to be used to make the camera follow the player, because if you're looking at the screen right now, if our player were to just start walking, at some point when he reaches the end of the camera view, he's just going to continue walking and we just won't see anything happen because the camera is static. It just doesn't move right now. So we have to create that. So the way we do this is with a script that we're going to actually add to our camera game object. So we're going to select the camera, and the first thing we do is we're going to just drag that into here. So let's go ahead and launch that. And as always, we're starting with a completely empty script here. And the first thing we'll do is we're going to create some variables. And these will be, we're going to need a reference to the player, and we'll just call this target. So we're going to assign the player transform to this, and we're making it public so that we can do that via the inspector. Then we're going to need to know what our left bounds are and what our right bounds are for our level, and that is so that the camera stops at the leftmost bounds and stops at the rightmost bounds and doesn't continue to go outside of the bounds depending on the player's position. And those are also public so that they're accessible via the inspector, so that we can assign our left bounds game object and our right bounds game object to those transforms. So we're going to create just a few more here. We also need to know our camera width, and to get that we need to have our camera height. So let's go ahead and create that variable as well. We're also going to need to know what our level min x and our level max x, and those are variables that we're going to use to specify our maximum leftmost position and minimum left most position and our maximum rightmost position. So let's go ahead and in our initialization method, let's get our camera's width. So if you'll remember from a couple of tutorials ago, there's camera.main.orthographic size times 2 gives us our height, and our width we just get by multiplying our camera height by our camera's aspect. So camera.main.aspect, and that'll give us the width. Okay. So now what we need is we need to actually know how wide the graphic is that we're using, and we know they're 32, but we want to make this more dynamic just in case something ever changes. We want the script to just automatically handle that. So we need to know what the width of our graphics are inside of our bounds, and we're going to get the left and the right, even though they're the same. Just like I said, if we change anything, we already have those values. The script handles it for us. So we create a float for the left bounds width, and that is going to equal left bounds, which is our transform variable that we created up top, which is a reference to our bounds game object transform. And we're going to get component and children, because all the sprites are actually children of the bounds game object, and we're going to get their sprite renderer. Okay, and we're going to get the bounds size, bound size x, and we're going to go ahead and divide that by 2. Then we're going to get right bounds width, and same thing here is right bounds, get component children, sprite renderer, bounds dot size dot x divided by 2. And again, we're dividing these by 2 because the pivot point is in the center, so we're going to need to only get half of their width. Okay, now we're going to calculate our level min x and our level max x. So we've got min x, and that's going to equal our left bounds x position plus the left bounds width, which is the left bounds width divided by 2, plus the camera's width divided by 2. Okay, and level max x is right bounds position dot x minus right bounds width minus the camera's width divided by 2. All right. So this takes care of most of our variables. And now we're going to go ahead and move to the update method. First thing we want to do is we want to check if our target has been instantiated. So basically we say if target, and then what we're going to do here is we're going to create a float target x equals mathf dot max, and I'm going to get into how this method works. Level min x mathf dot min. We're going to do level max x target dot position. Oops. X target dot position dot x. Okay. The target x position, we're getting that by using a mathf method named max. And max, what max does is it returns the larger of two values that are passed in. Here we're passing in the minimum x, okay, and we're passing in another mathf, but this time we're using dot min, which actually gets the smaller of two values. And the smaller of two values here, we're passing in level max x as one of the values, and target position x, okay. So it's going to grab the smaller of these two values, and at any point in time, level max x basically equals the rightmost bounds of the level, okay, and the target's position is the dynamic value that changes as the player moves back and forth on the platforms. So as the player approaches the level max x position, his position is constantly increasing towards that level max x. So he's constantly going to be the smaller of the two until he actually exceeds that. So for right now, let's just pretend that the player is constantly below that level max x. So what we're going to be returning here is the minimum number. So that would be the player's position. Okay. So then what we're passing to mathf max is the level min x, which is the leftmost position, and then we've got the lower position here, which is the player's, and then we're comparing. We want the larger of the two. So if the player is the larger of the two, then the target x is going to be the player. Okay, so yeah, level min x will only ever be larger than the player's position if the player moves further than, or tries to move further than the level min. Okay, so when that happens, then the target x will be level min x, and so basically what we're creating here is a variable for the position of the camera. So we never want the position of the camera to exceed level max x, and we don't want it to go any further left than level min x. And that's what this that's what these two mathf functions help us solve. Basically a minimum and maximum of our two values. So in order to make all this work, let's create another variable here. Let's call it float x. And we're going to use another mathf method, and this one is called smooth damp. And before we can actually use this smooth damp method, let's create a smooth damp time, which is one of the values that we actually need to pass in. And smooth damp time for this method is basically the approximate time that it's going to take from our original position to our target position. So we're going to set that to be a pretty low number. I'm going to go with 0.15 f for a smooth damp time. So here in our smooth damp method, if you'll look at it, we'll see it wants a current position, a target position. It also wants a reference to a current velocity and a smooth time. We also need to create a current velocity variable, and that is actually going to be a vector 3. Alright, so let's go ahead and fill this in. What we're going to put in the for the original position is I'm going to grab the player's position, so the camera's position. So transform.position.x. Okay, since the script is attached directly to the main camera object, we can just grab its transform. So that'll be its x position. And then we're going to use our target x variable that we calculated up here for our target. And then we're going to add smooth damp, let's see here, smooth damp velocity vector that we created, and our smooth damp time. Okay. Alright, so that's going to calculate an x for us, an x position for our camera. Okay. Then all we need to do to actually make that happen is we need to set the camera's transform position equals a new vector 3, and we're going to pass it the x value that we've calculated, and then its original transform dot y and its original transform dot x, or sorry, dot z. Because we aren't changing, and it's not transform.z, it's transform.position. Y. Transform.position.z. So yeah, we're passing it its original y and its original z position because we're not modifying those. In other, more modern platformers, they do update the y. In the original Mario, they did not. So I tried to keep this as original as I could with our clone. So we're not going to be modifying the y position of the camera, just the x. And again, so what we're doing is we're creating a target x float using a mathf.max and a mathf.min to get the larger of two values to give us a variable or a position that we can use as a target position for our camera that stays within our bounds. And then what we're doing with that is we're applying a smooth damp method from our original position to our target position by a specific amount of time, so that the camera follows the player smoothly and doesn't look all jaggedy and stuff. So that's basically what all this does. And then finally, we are assigning this X position that we created to our camera's position. And that is pretty much all there is to the camera follow script. Our next tutorial is going to cover some basic player movement and some other fun stuff. So stay tuned for that, and I'll see you guys soon.